You've got 10,000 tasks and you page through them, 20 at a time. With offset paging, page 2 means skip 20, take 20. But between page 1 and page 2, someone adds a task or deletes one. Now the whole list has shifted underneath you, and page 2 either repeats a row you already saw or skips one entirely. The fix is cursor pagination. Instead of skip 20, you say the 20 after this exact row, and the window can't drift. Here's why offset drifts. Page 1 returns rows 1 through 20. Offset 0, limit 20. Then a new task gets inserted at the top, and every existing row shifts down by 1. Now page 2 asks for offset 20, but offset 20 now points at the row that used to be 19. So the client sees row 20 a second time. Insert a row, you repeat one. Delete a row, you skip one. The more the list changes, the worse it gets. Cursor paging fixes it. The first page returns 20 tasks and an opaque cursor, a black box token that marks the last row you saw. It comes back as an RFC 8288 link header, rel next, with the full URL for the next page. To continue, the client just follows that link. It sends the cursor back, and the server returns the 20 rows after that exact one. Insert or delete anything else, and it doesn't matter. The cursor still points at the same row. No offset, no drift, no skipped or repeated tasks. And here's the endpoint. The repository overfetches. It asks for limit +1 rows, so it knows whether a next page exists, and Trellis's PageBuilder trims them into a page, encoding a cursor from the last row it kept. Then ToHttpResponse does the HTTP part. You hand it a next URL builder, how to turn a cursor into the next URL, and a body projector for each item. Trellis returns a 200 with the paged body and emits the RFC 8288 link header pointing at the next page. The client never computes an offset, it just follows the link. So cursor pagination makes 3 promises. 1. You page by cursor, not by offset, the 20 rows after this one. So a row inserted or deleted somewhere else never shifts your window, and you never skip or repeat. 2. The server overfetches, asking for limit +1, so it knows whether a next page exists, and hands back an opaque cursor the client treats as a black box. 3. That next page arrives as an RFC 8288 link header, rel next. The client just follows it, no offset arithmetic. It's forward only, and the page size is capped, 50 by default, 100 max, so no client can ask for 1,000,000 rows at once. Cursor pagination turns paging from a guess into a guarantee. The window pins to a row instead of an offset, so the list can change all at once and you still see every task exactly once. Trellis gives you page, cursor, and the RFC 8288 link header out of the box. Next, when a request is invalid, we point the client at the exact bad field level errors with JSON pointer. Subscribe, and I'll see you there.